have this theory that it's not a theory, it's their opinion or their guess, unencumbered by the thought process mostly. But a theory is a hypothesis that has now been supported by multiple experiments or multiple studies over time. Right? So when we say the theory of evolution, this is not just everybody said, well, Charlie Darwin guessed this and it sounds good, so we're going with it. Right? There's actually evidence behind it, and that came up in some of the discussions too. All right, so when you were this kind of scientist, where did those observations come from? What? Like this guy.
From natural world.
Well, true. Who made those observations? Like this guy. What's he known for?
Gravity.
Okay, based on the mythos says what?
An apple dropped on his head.
Yeah, so who made the observation? He did. Same thing with Galileo. It's like his observation was, I look at things through my telescope and I gather data and then I make a hypothesis that the moons go around Jupiter. Don't tell Dr. Dunn I said it that way. Same thing with these guys. Darwin did what? He traveled on the Beagle, right? And same thing with Wallace. Wallace was actually in the South Pacific when he made his observations, developed his hypothesis, developed his model, and then wrote Darwin and said, here's what I'm thinking, what do you think? And then, actually I think it was Huxley said, you need to publish now, man. So in their day, right, really the only thing you had was you made the observations, you collected the data, you wrote it up, you developed hypotheses, you developed theories, and all the observations came from the scientist. Now, what do we have?
We use what they built.
Well, true, but in terms of, so we can use what they wrote about as observations. They're still valid observations. And we still make observations. What do we call that? When do people like us make observations? During what part of the process?
Experiments.
During the experiments or going out in the field and collecting, right? So we make observations. And then when there's another very important resource, which would be what?
Instrumentation.
Well, but I would say that's still us making the observations. Even though we're using an instrument to do it.
So it's a Mars rover. It's dramatic. Yeah.
Well, okay, that's actually kind of a good point. Okay, so people, so a lot of people could be using data from the Mars rover, but they're not the ones at JPL that are actually downloading stuff, right? Because JPL and NASA puts it in a database, so we can use other people's observations, right? And the same thing, well, so where else would it show up? Where other people report their observations, and then we can use, sort of in a vicarious way, their observations to either supplement or substitute for our ability to make observations. What do we call that? Sort of.
Analyzing.
Yeah, but so other people make observations, and then they do what?
Right.
They publish it. So one of the reasons that everybody nowadays has to learn how to read the primary literature is the primary literature is now a source of observations for us, right? We can use those observations just as well as going outside and finding things on our own. So, for example, in our project, we use the observation that people looked at seagulls in Portugal and saw that they were coming in with certain sets of microorganisms. And And these microorganisms had certain resistances to certain antimicrobial agents. Right? We have another report, another observation was made that the same thing happens in the UK. So those observations plus our observations that we make in Wichita Falls then lead to the next step, right? So we have questions. And from those questions, then you say, what? What develops out of those questions? The hypothesis, right? And the hypothesis is it's supposed to be the answer to the question. All right, so let me do this. So I'm going to try this kind of question. Right, so here are some guppies. And when guppies get together, the males will make these displays. And they call them a sigmoid display because for part of it, the male guppy sort of bends his body into the shape of an S or in a hook. And the idea is that a gas, he gets to display his big tail fin and the dorsal fin, but then can still keep an eye on the female. I think is what's going on. Right, so I'm going to give you this scenario, these observations, and then we're going to
Thinking.
right, we can do it without the video, just let the video is.
This computer needs to be it's very slow.
Wow. All right. Okay, so right now, this is sort of undirected. Somebody has an aquarium and they observe these things, right? So then we set up sort of an artificial scenario. So you have So you have 2 tanks, 2 aquaria, one with like 8 to 10 males, one with 8 to 10 females. The actual experimental setup you have a partitioned tank, and there's a clear partition, and then there's an opaque partition. So that you can actually move fish around and they won't know what's going on at the beginning. So you put in, say, a male and a female, and then you pull up the opaque screen, now they can see each other. All right, before this, you take some measurements just to collect some numbers. The males are 28 to 36 millimeters in tail length, which is from the nose to the end of the tail. Females are slightly larger, which is typical for guppies. You can do a proportion looking at the tails. So some of them, it's a quarter of their body, and some of them are getting to be close to 40% of the total length is tail. All right, so, and you also notice that some of the males are sort of reddish, and some of the males are more on the yellow side. So you put in a red male and a female over here. And what they're talking about, the postural changes is that sigmoid display. So you can sit there with a stopwatch, and in 5 minutes, the male makes 4 postural changes. And you notice that the female, the first female you try this with, makes 8 approaches towards the panel, to the screen. Right? They can't touch each other because there's glass in it. So you pull her out, you put in another female, she makes 6 approaches, and the male does about the same, 4 changes. All right, so now you swap out the red, you put in a yellow male. I'm sort of reading into the scenario that they use the same female. She makes 3 approaches, even though he does it 6 times. And you pull her out, put in another female, and she does 5 approaches. All right, so you try this with 3 more pairs. You get similar responses by the males. So 4 or 5 postural changes. But in these 3 additional pairs, only 2 of the females approach the partition at all. So just observations. All right. I guess I didn't dedicate time to. So we can change the scenario a little bit too, as you put in 5 males together. If you have 5 males over here and 1 female over here, then the males end up doing about the same frequency of display, but they're a little more vigorous, which you can kind of see at the video. If you put in several males and several females, you get similar types of responses in terms of numbers, but the males tend to do it to only certain females. All right? So, those are your observations. So what kind of questions can we come up with?
Why did they pick single out a female?
What else?
Why did the females approach the ring-tailed males more?
Okay. Those are 2 good questions. Maybe those are what we should start with. There's probably one other one, but it's going to be hard to suss out. I think it has to do with this one.
Why did that other female not approach?
Yeah, so we did this, if we did this like 5 times, well, 4 or 5 times, maybe 5 or 6 times. And so 2 of them evidently weren't interested at all. So what do we call that? All right, so these are the things. You make observations. You say, I wonder why that happens. Or I wonder how that happens, which is actually a better way to ask questions in biology. You want to say, how does this occur? By what mechanism does this occur? What's the advantage to do this, rather than asking why? Because why implies intent. And in most cases, there's no intent. I mean, certainly, a bacterium doesn't intend to do anything. All right, so here's our questions. What I want you guys to do now, so go back and work in your groups. What I want you to do is maybe just pick, should we pick a question? Maybe let's do this. Let's pick one of these questions to play. So which one do you like the best?
First.
This one, why only certain females? Okay. So we're going to work with this. And I want you to do 2 things. Right? So I'll give you a little bit of explanation first. So you have a question, what do you do next in science? Make a hypothesis. So we hypothesize that. Blah, 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 blah. Okay. And then what do you do next?
Test.
Test the hypothesis. How do you do that? What are you actually doing? You're doing an experiment, so how did you determine which experiment to do? Where did that come from? What do you mean by observation? Because the original observations led to the question. Why, in this case, why did the males display preferentially to certain females? And then we say, well, I hypothesize, or we hypothesize, that the males are